They are called registers. Registers are a group of mostly D-type flip-flops. Mostly D-type flip-flops or latches, depending of the applications. Let's focus for now for flip-flops only. And D-type flip-flops because the register are to store the bits, the sequences, the information. And in the most cases, in the majority of cases, simply you put what you'd like to get, and it is the operation of D-type flip-flop. So that's why we are using. Let's confine ourselves to 2-bit only register, the simplest one, which consists of 2 of them. And the rule is the following. We are considering fully synchronized devices, including registers. That's why we connect clocks together. All the flip-flops will have always, in this course at least, the common clock input. So you simply, if you apply a group of flip-flops or latches in the same circuitry and the same system, you simply, the first thing you do is to connect them together, the clock inputs. Then, as you know, in the case of D flip-flop, you've got D and Q. I will omit, not Q output, because I'd like to have the same information, not the inverted one. But of course, you must be aware that there is in each of the flip-flops there is another output which is inverted. So the input, I will draw them here to have an input, and let's call them x1, x0, because they constitute a one sequence. It can be a number, in binary or so on. And similarly, I will denote outputs as y as being y1 and y0, okay, as being 1, and ck is a common clock. All right, so I think you know how to expand it to get an, in general, n-bit version of this register. Will you be able to do it? Or simply imagine that you are able? Simply you add another one, and only clock should be connected, clock inputs, yes? The D inputs are denoted at x's, xi, etc., and they are separated from each other. And the same is true for outputs, line wise. Okay, so it is a series. Yes, they have common clock, but the input and this kind of register is called the parallel register. It is a parallel because you put all the bits together in one at the same time, and you clock to have them stored into Ys. Okay, so a single clock is needed, and is enough to store this information from input to output. And this type of register are very common in microprocessors, microcontrollers. Okay, they are registers which are close to the CPU. The closest ones are built in this way. And memory blocks, which are dynamic or static memory blocks, are constructed in a different way, having only one transistor for one bit, or even less, one transistor for several bits. Okay, they are dense. The technology is quite different. We are now concentrating on these devices, which are made of gates and then flip-flops and then registers and so on. Okay. We don't consider the memory blocks, which are separate. For now, I will introduce memories, perhaps in the last lecture. Okay, so now your task is to derive the description of this. Let's confine to 2-bit version and try to derive all the forms you know to describe STD, STD, and so on, and so on. So ST, STT first, STT, the simplest STT for this. Well, the simplest is the very straightforward in terms of ones and zeros. That's all. If you'd like to put q's above, you can put a q of t and q of t plus 1, the same, q0. And these are q of t plus 1 after the clock. If you put 0, 0 and you clock the system, you get 0, 0. Very simple. STE. STEs, there are two STEs. One is the straightforward y. It is a vector containing 2 bits. Okay, let's say it is y, which consists of y1, y0. To cut the thing short, I will use the vector equations in vector forms. If y is equal to q of t and q of t plus 1 equals what? X, of course. Yes, it is the same as the equation for D-type flip-flop. And the most difficult, but not too difficult, is to find the STD of this. Could you draw the diagram by yourself? I will stop the... Okay, so let's erase this table. It is not the standard one. Be aware of this, because in the case of the standard ones, I should deliver the current state, the current X, and the table will have 16 rows. Too little time. We have too little time to present the full table. That's why I have shortened it, this table. But I will not short the STD. And a good starting point is to draw all the possible states of the register, of the machine, of the Moore machine. And these are 0, 0, 0, 1, 1, 0, and 1, 1. Okay, these are Q's at the same time Y's, because Y is equal to Q. And when you go from 0, 0 to 0, 1, when you put 0, 1 on the X, on X input, so you put 0, 1 on this above. So what you put, you will get after clock, okay? So in order to be clear with this diagram, please put inputs closer to the current state, not closer, not in the middle between the states, and at the end of the arrow, closer to the current state. Okay, so you must have 4 lines that end with 0, 1, having 0, 1 aside these arrows. So let's do another way. As I said, 0, 1 closer to the current state, 0, 1, and 0, 1. I will change the color to draw all the arrows for 0, 0 as target, the next state, 0, 0, the next state. And this is the first arrow, it is 0, 0. Here, the second with 0, 0, the third with 0, 0, and the fourth with 0, 0. Okay, is it clear for you how to complete this diagram? Take one state and draw all the lines or all the arrows which target is the current state, okay? The selected state. Okay? So many, and that's why it is a very unclear way to describe registers. It is a very clear to deliver this or simply look at the diagram. It is a very clear, and this is not clear. That's why for the registers we very seldom draw the full diagram, at least for this kind of parallel register. Parallel in, parallel out, parallel in, parallel out. Okay, are you comfortable with this? Can I switch to another type of register or something? Okay, I can switch, thank you. And now, let's consider this kind of the register. where the flip-flops are, as usual, they must be connected with clocks together. But instead of having independent input for each of them, you've got only a single input, which is called input right. Why right but not left? Because it is on the left. Because after clock, the information is shifted to the right. It is a shift right register. Okay. If you clock, let's say by triggering with rising edge, this information, and let's call it Q1, will be copied, transmitted to Q0. Okay, because D will be Q1 and will be transferred to Q0. It is shifted to the right, and that's why it is shift register, shift right register. Not parallel input. You've got a serial input. It's called input right, but it is on the left. Okay, but it is called input right. And similarly, you've got the D and Q. They are, yes, well-known flip-flops, and you must have Q1 for the user to the output. So your Y1 is here and your Y0 is here. Okay, it is a very similar structure, but not having separate inputs. You've got a common input, and you put the information in series from left to right using an input right. Okay, and so let's derive STT. So now I will expand the table to have it the standard way, to have it constructed in a standard way. So you've got the input right. For the first time, I am using two letters to denote a single input. Apart from reset and set, be aware of it. It is a single input right. IR, not separate two, not two separate inputs. So input rights we can change it into inp or something else if you want, but I will stick with this. Q1 of T and Q0 of T are the states, and a single input is input right. Okay. So the standard table will contain Q1 of T plus 1, Q0 of T plus 1, and because Y is always equals to Q, because it's a Moore machine, very simple Moore machine without any gates on the outputs, on the Qs. So we don't need to put Ys here because they are always equal to Q1 of T and Q0 of T. So I will omit filling in Ys because they are the same as Qs. So now your task is to fill in this table with all the possible combinations, because you have a free choice of this. You can have any initial state, I mean Q1 of T and Q0 of T can be any values, and you've got a free choice what to put of input right. So any sequence can be possible. Okay, it's high time to stop my recordings because I don't have more than 15 minutes, so I will stop it, and your task is to continue, to complete this task, to deliver STE and STD and STT, of course, STE, STD, and STT. And do it now, please.